Going over section 6.1, angle bisectors and perpendicular bisectors. In exercise 3, we saw that this is a perpendicular bisector, so GH has to be 4.6. And number 4, if these are both 4.7 and this passes through here, this must be a perpendicular bisector, so QR is also 1.3. In exercise 5, we need to find AB. We see the perpendicular bisector. It must be a perpendicular bisector because AD is equal to DC. This is perpendicular. So we're going to set up an equation and solve it. So 5x must equal 4x plus 3. Subtract 4x, and we get x equals 3. Is not what they ask for. They ask for AB. So AB is 5 times x, so that would be 15. In number 6, again, another perpendicular bisector problem we'd solve in much the same way. Number 7, is this a perpendicular bisector? We see that KN is perpendicular. It goes through N, and LN and MN are equal, so that only happens if LK equals KM, so yes. Is this a perpendicular bisector? Well, we don't know anything about either LP and PM or NM being congruent to LN, so no, that's not what we don't know that it's a perpendicular bisector. Moving along to a question about an angle bisector. If we see the distance from each of those rays is equal, we know that this must be an angle bisector, so 20 and 20. Here we have another angle bisector problem, and so PS must equal SR. They're both 12. In number 13, the measure of angle KJL. This is, again, another angle bisector problem. Let's go ahead and solve this one. So if it's an angle bisector, we know 7x equals 3x plus 16. So 4x equals 16, and if we divide both those by 4, we get x equals 4. They want KJL, which is equal to 7x. So 7 times 4 is 28. Another angle bisector problem we'd set up the same way. And more of the same until we get to question 19, which I've made a video about already. Classifying triangles by its sides. We should be experts at this by now. All right, that was 6.1, 6.2 coming up.